Hey pinball fans, Butch Peel with Jersey Jack Pinball. So many interesting things going on underneath a pinball machine playfield. I figured we needed a series of videos to look in detail at the way some of these things work, things that we can do to adjust them, to align them, to make them work properly, and things that we need to keep an eye on and watch out for wear on so that we can replace them and keep them working at their best. This is the first in a series of videos to that effect, and we're going to look at flipper assemblies today, of which on the Wizard of Oz there are quite a few of them. They're pretty much everywhere under this playfield. So if you're ready, let's get going. Here's a right flipper assembly demonstration device that I put together using plexiglass. It's completely wired into my Wizard of Oz pinball machine with the coil, end of stroke switch, and flipper cabinet switch, so it's fully functional. As I said, this is a right flipper assembly. The difference between a left flipper and a right flipper, basically there's two parts. The flipper base plate itself is configured just a little bit differently, so there's a right base and there's a left base. There's also a right crank and a left crank. If you notice this piece here and here, that is just reversed. Basically the arm comes off the other side, and of course this screw and this bolt are put in backwards with the return spring holder there on the opposite side also. A quick word of caution when dealing with flipper assemblies: if you've got the power on in the game and you're underneath the playfield and you've got your coin door closed, the coil is energized, and that means these three lugs here all have 70 volts across them. So when you touch those, you will know it, whether it be your knuckle or your finger or someone bystander just helping you, something like that. They're going to know it if they touch those lugs. Those are energized. However, our switches are low voltage, so the flipper switch there, the end of stroke switch, those aren't going to hurt you at all. You just have to watch out for the lugs on the coil. And there is an interlock switch on the coin door so that when it's open, it disables high voltage underneath the playfield. So all three of those lugs will be disabled. However, it's just a better idea if you're not needing to use power to test what's under the playfield. You don't need to test it under power. It's just better to work on the game under the playfield with the power on the game turned off. So just keep that in mind. The first adjustment point on a flipper assembly is the end of stroke switch. That's this switch here that lies alongside the coil. Using a switch adjustment tool, I like to bend both blades of an end of stroke switch slightly outward, away from the actuator. You can see when I push the plunger in that the actuator is what actually closes the end of stroke switch. I want it to not only touch right at the end, but I want it to follow through and push that back blade that way just a little bit. I want to make sure that it makes a good connection. So the way that I bend those blades outward with my adjustment tool, the end of stroke switch is basically a leaf switch. So leaf switches, we always bend the blades as close to the stack as possible, as close to this point where they attach these little screws as possible. So I'm going to take my adjustment tool and I'm going to put it on the very end here, and I'm going to gently bend each of these blades outward. And I'm going to leave a small gap in between there so that when my flipper kicks, it closes the gap and makes the switch. The switch is normally open, so the blades cannot touch one another until that end of stroke is reached. I can check the adjustment with my hand by pushing on the end of this plunger here. I don't want to push on the back here of this elbow because there's play in this joint and there's play in this joint that will mess up my adjustment. So I just want to pull the plunger itself into the coil like so and push it until it hits the coil stop at the opposite end. So the end of the plunger hits the opposite end of the coil stop over here. And make sure that my switch makes and follows through just a little bit as that plunger hits the coil stop. The reason I like to bend those leaf blades just a little bit is the flipper is a very violent assembly, and if this actuator has to really push those blades a long ways to make contact. If this one were straight out, it would get pushed and bent severely each time the flipper kicked. Whereas now I've got it bent back a little bit, it only travels a short distance and it's kind of already bent in that direction so that it's easier on that blade. Less chance of it snapping off over time. So my final check with the end of stroke switches is an electrical check to make sure that everything's making contact and that the computer inside the game recognizes that switch opening and closing. So I've got the game set up in its dedicated switch test mode. So when these dedicated switches like the end of stroke switch are made, I'll hear the game make a sound. So it makes a sound when it closes and it makes a sound when it opens. And I can check it manually or I can check it with the switch. That makes sure that the end of stroke switch is capable of doing what it's supposed to do in the game, telling the game that the flipper is indeed at the end of its stroke. There's an adjustment to the cabinet flipper switches inside the cabinet. You lift your playfield up as I've done here in my Wizard of Oz game, and you see this is a double flipper switch. It has two sets of contacts, so the inner one activates the lower flipper and the outer one activates the upper flipper. So I can do that independently. I can flip each flipper independently, or a quick push of the button flips them both simultaneously. You want to keep a gap, kind of like I've shown here, between them, make them equidistant. This innermost blade, you want to keep a little outward bend on it so that it pushes the flipper button back out. When we look at the flipper cabinet switch from another perspective, inside the cabinet, you see that it's not near as simple a leaf switch as was the end of stroke switch with the flipper assembly. This one's a little bit more complex. So it has two contacts, two blades on the inner part for actuating the lower flipper, like I said, and two blades on the opposite side for actuating the upper flipper. And they're separated by a piece of what we call fish paper. It's an insulating material. So when I want to close the gap for the lower flipper, I'm also going to have to bend the one contact blade for the upper flipper at the same time. In other words, all three of those pieces will be bent at the same time to close that gap for the lower flipper. And the outer blade has a stiffener on it, which basically pushes the blade inward or allows it to come outward as I bend this. See how it follows the stiffener? I'm not bending the blade, I'm just pulling on this stiffener here. So I can use my switch adjuster tool there and I can bend the stiffener to close that gap or open that gap a little bit. And now I'm able to do that because this blade here has good positive pressure against that stiffener. It wants to follow it. You know, it's pushing against the stiffener, so the stiffener then controls the exact gap for it. And that's how you adjust for the upper flipper. This is what a flipper bushing looks like. It's a nylon piece that goes through the flipper base plate. You can see it there in my assembly. Through the base plate, all the way up through the playfield, and the shaft of the flipper bat rides inside the hole and goes completely through the playfield and into the assembly underneath. And it's tightened with this nut on here to hold the shaft of the flipper. Now, it's really important that the flipper bat and the shaft of the bat in particular does not get bound in any way. No binding is going on. So there's a little bit of a gap in here. And you see when you turn the flipper kind of partially between, halfway in between its end of stroke and where it lies in its normal state, you should be able to move it up and down inside that flipper bushing with a little bit of play, and that makes sure that the flipper bat does not bind. If you don't have this little bit of play in there, your flipper bat will set on top of this nylon here, and the bottom part of the bat will actually start grabbing the nylon here as it tries to flip, and it'll make for a very weak flipper. And of course, the amount of play you have between the bottom of your flipper bat and the top of that flipper bushing is defined by where you mount the crank portion of the flipper assembly underneath on the shaft of the flipper bat. So this goes up and down. If you get it too close to there and you get this too tight, the flipper will bind. The exact amount of play in this flipper bat is not really a critical thing. It's just important that it have a gap in there and that you have freedom of movement for that flipper. There is a tool they use to come in a Williams goodie bag in the bottom of their cabinet. You can find these at shows and on their junk tables, or I think even Marco sells new ones on their website. But this is a flipper adjustment tool, and it's used to kind of make that gap a little more predictable for you. So to use this tool, you just put the cutout here around the shaft of the flipper bat, align it like so, and make sure that it's all the way around, and it provides your gap now. Then you lift your playfield up, and now you tighten the crank down where there's basically no play at all. It's right against the bottom of the flipper bushing there. And when you're finished, bring your playfield back up, you pull out the tool, and now it created the gap that you need to keep your flipper from binding. One last note, when you're attaching the crank to the shaft of the flipper bat, I'm going to show you a brand new piece here. You see the gap in between here where these two pieces, this nut pulls these together. This gap will close as this tightens around the shaft of the flipper. Now I'm going to zoom in on the assembly here so you can get a better look at it. That's a fully tightened one. So the gap closed quite a bit. You do not want to over tighten this to the point where that gap completely closes. If it does, you'll have a tight flipper for this one time. If you ever take it loose, you will not be able to get it tight enough to hold that shaft in place anymore. You'll have basically made this into a one-use piece. You don't want to do that. So always when you're tightening the crank onto the shaft, tighten a little bit, check it on the top, make sure. Maybe even play a game and see if the flipper moves when you're playing the game, and adjust where its rest position is. It comes up in a different spot each time. If it does that, you pull it back to where you need it to be, align it again, and then you tighten it a little bit more and try it again. Tighten it a little bit more, but do not over tighten this. Don't ever close that gap all the way. The last flipper adjustment, or alignment to be more specific, and this is done in conjunction with tightening the cranks onto the shafts of the flipper bats underneath the playfield, is to align your flipper bats with the return guides here on either side, so that the ball rolls smoothly off of the guide onto the flipper. And you can also use these little holes that are pre-drilled in the playfield as reference points. So if I line one of these up and set it to where the hole is just on the inside of the flipper bat, I want to do the exact same thing on the opposite side, so that when I'm finished with my alignment and tightening my flippers down, my flippers appear symmetrical to one another in the rest position and in the fully extended or kip position. They still look symmetrical. So the way I accomplish this is I get my gap set up so that my flipper bat does not bind. I set that up with the little small gap that I showed you earlier, and I tighten things down pretty snug, not completely tight, because I still want to be able to rotate the flipper bat on the shaft underneath, so I can align it properly with, how I want it to look on the playfield. So once I get it aligned properly, I tighten it down really good and tight, and then I play games and check and make sure that when it flips up, it flips to that normal position and it returns where I want it. If it's not tight enough, that flipper bat will work its way down each time I flip it, and that means I just need to readjust it and tighten it again. Things you want to check periodically to make sure they're tight are all the screws that hold the mechanism to the underside of the playfield. There's 8 of them on this flipper assembly. You want to make sure that your end of stroke switch stays tight, so these 2 screws are tight. You want to make sure this screw, there's a nut underneath here, and this cap screw right here can work its way loose sometimes. It's really hard on that elbow joint when it gets loose, so you should not be able to turn that with your hand. It should be tight all the time. There are also two screws, cap screws, holding in the coil stop. Those should be tight, really tight all the time, and the two screws holding the coil in place. These Phillips should be tight. In addition to the three screws that hold the flipper bushing, this big white plastic circle here in place. From above, the plexiglass allows you to see the three nuts that are used on the opposite ends of those three screws that hold this flipper bushing in place. So the flipper bushing goes through in this direction from underneath the playfield, connects to the opposite side of that flipper base plate with three Phillips head screws that go clear through the base plate, and then have these three nuts attached to them. Those three nuts there sometimes will make their way loose also, and you'll find them in the bottom of your cabinet. And what you'll have to do is pull the flipper mech completely off the bottom of the playfield, put the screws back into the nuts, tighten everything securely, and then put it all back together again. The last thing I want to talk about is wear parts on the flipper. Parts that are going to wear out need to be replaced. You'll need to check periodically to make sure your flipper is working the best it can. I'm going to zoom in a little bit here. First of all is the flipper return spring. So this spring is what pulls the flipper back to its rest position from the kick position. Those do break from time to time. Generally they break right here near the end on the loop here. But you just buy a new spring and the loop will open up and connect here and connect here for pretty simple replacement. The end of stroke switch sometimes will wear out. They have gold plated contacts, and so occasionally after a period of time the gold will wear off those contacts and the switch won't make very well anymore. It's two screws and two solder joints to replace that end of stroke switch. You can buy new ones of those separately. On rare occasions the flipper bushing can break. They sometimes crack and break right here near the base where they go up and through the playfield. And you'll notice that your flipper is very weak and it has a lot of play in it. When you grab the flipper bat from above and move it, it has a lot of play in it, and you can tell that this has been broken. It needs to be replaced. A lot of times people replace these when they're rebuilding flippers and changing out parts, just because they get kind of gunked up down in the hole there. A lot of black soot and things like that get down into this hole and kind of inhibit the shaft of the flipper from turning inside there. So a good clean set of these every time you rebuild your flippers will keep that from happening also. When I say flipper rebuild, the typical parts in a flipper rebuild are the crank and pawl assembly here, and the plunger and link, this whole piece. The coil stop will get worn, and end of stroke switch and spring. Those are the kind of things that normally come in a flipper rebuild kit. And you can buy Williams flipper rebuild kits online at many places. Those will work just fine for Jersey Jack pinballs. So the main physical wear type parts on the flipper mechanism are the coil stop here. That fits back in the back there, holds the back of the coil in place, and the pawl and crank, flipper plunger and link assembly, this entire piece right here. And that's the part that sits inside the flipper coil. And what happens when the flipper flips is this plunger smashes into the coil stop like so, over and over again when the flipper reaches its end of stroke. So if we look in detail at these main wear parts on the flipper, you see here's brand new parts in the foreground, and in the background are worn parts. So the coil stop starts off nice and smooth and round and flat. As it wears, it gets a dimple in it like that. It gets mushroomed out, and this becomes kind of difficult to pull out of the end of the coil because it catches on the coil sleeve, because this lip here sticks out so far. The plunger and link, when they're smacking into that, they have the same problem. Nice and beveled on a brand new piece, very flat, mushroomed out on a worn one. So this lip again starts to catch on the coil sleeve that sits inside the coil, and any resistance to that plunger moving in and out translates into weak coil and weak flipper. So remember when I made the note about keeping this cap screw and nut pretty tight here, making sure that that stays nice and tight. That becomes really important because when that nut gets loose, it causes wear in this elbow joint right here. So if I look at a new piece right here and I can check out its play in it, it's pretty tight. It doesn't have much play in it. A worn piece, however, at this joint right here has all kinds of play. Look at all that movement. All that movement then keeps this elbow from doing its job, which is just to make that turn there. If it has play in it, it takes away from my flipper strength. So I've loosened this up a bit to kind of show you what's actually causing this loose joint here and what the wear looks like. So we have a cap screw that goes all the way through. Inside here now is a little metal bushing. It just fell out there. So this little metal bushing rides inside this hole right here. And the screw actually goes through the center of that to hold it all together. But you see all the play in there, and that's from the wear. This hole here should be round, not oblong like that. And the same thing can occur with this hole. It can develop a little bit of wear in there and become oblong also. And the two of them combine to make for a very, very weak flipper. Combined, of course, with this rubbing on the inside of your coil sleeve, resisting the plunger wanting to go inside, the weakness in the elbows can make for a very weak flipper. So you need to replace these parts periodically. They are wear parts. Other parts that can wear on that crank, if you look at where the heat shrink tubing here makes contact, this arm makes contact with the end of stroke switch, that constant rubbing on that blade tends to make the heat shrink tubing wear and makes a place here where now if this can start peeling up just a little bit, it can catch on the end of stroke and stick your flipper in the up position all the time to where it doesn't want to go to its rest position. It's hung up on that end of stroke switch blade. So you just basically pull this off. You can replace that with a 1/4 inch piece of heat shrink tubing, just cut to length and heat shrink it back onto there. That's good to go again. If you look at the other side of this, where the spring that pulls the flipper back to its rest position hooks in, the return spring, it can actually wear into the metal there and cause that metal to fail, and the loop will then pull out the other end. That happens time to time. You can replace just this single part here, or as I said earlier, we just kind of replace the whole flipper pawl, plunger and link assembly, crank, all that stuff, spring, as part of a rebuild kit periodically when we notice our flippers are getting weak. Last but certainly not least, when it comes to wear parts, on the top side of the playfield are the flipper bat itself and the rubber ring that go on it. The flipper bats can crack from time to time. Flipper is a very violent assembly, as I mentioned before. The metal ball, steel ball, is smashing into this flipper bat all the time, so the bat is plastic. Metal versus plastic, you know what's going to win that battle. So you can replace the entire bat and shaft assembly and go through all the steps we went through earlier in the video to replace that. You can also change the color of your flipper bats. They come in a variety of colors, so you can change it and make your game look the way you want it to look. Same thing with the flipper rubber rings. There's a variety of styles and colors and different types of rubber rings that can go on a flipper bat and make it look the way you want it in your game. They will wear, the rubber rings, from over a period of time as the ball hits the tip, especially here when you're trying to make saves and the ball going down the middle. The rubber ring will wear here at the edge, and you'll need to replace that from time to time. Keeping them clean though, and the black stuff off of them will make them last a lot longer in your games. Well, I won't say that's all I know about flippers, but it's getting pretty close. So until we meet again in the next video, keep on flipping. Go challenge one of your friends to a great game of pinball. Take care, guys.